This is IBM Museum. On this video, I'm back in front of the IBM PS2 Model 30 with my glasses on. This is the original version that was released in April of 1987 based on the 8086 CPU. I wanted to go over one of the unique registers that's on this unit. It's on this unit for the IBM systems and of the Model 30, also on the Model 25, which is derived largely from the Model 30 design. The Model 25 just doesn't have that real-time clock. I'm still working on a little bit of the angles for a video with the real-time clock functionality, since that's unique for that clock chip on this model that no other PS2s had. But I wanted to show this register, which is it's actually a planar functions control register. And so let me go through, get to the video capture here, and we're not necessarily going to use the full screen I/O viewer in that regard for this area. We're just going to simply use DEBUG. We are going to use the UMPC utility program to, in fact, let me go through and start that up just to kind of show the areas that I'm going to go over. Okay. So in the UMPC program, and I apologize for the video jumping around and refreshing. I want to look through for the parallel ports, and we see that it's got a listing of a parallel port at IO address 0378, and that is active. It's not in extended mode, but it is active. Stepping back, going to the serial port, we have a single serial port at that address of 03F8. It is active, and then it explains the basic UART type that's of that system. We're wanting to pay attention in particular to that active setting of how the UMPC program is seeing that. So let's go through and escape all the way back out to the DOS prompt. And we're going to start up the DOS debug program. And in this instance, we just do an I and then the planar features control register, which is 65 hex. And DOS debug, works natively in that hexadecimal mode. You can't give it decimal numbers. You have to operate in hexadecimal. This is just saying I want input from port 65 hex. And it's giving me a value of 9A hex is what's controlled in that register. And I work a lot with hexadecimal to go through and kind of I jokingly say even that you can teach kids with the fingers of both hands to count effectively from 0 all the way up to 255. And that's using the thumbs to hold down the bits, as it were. I'm just trying to go through and represent. I'll have to see how it shows up on the screen for ultimately what's my right hand and left hand as a way to represent the 9A value. And basically it's that for 9, and then A is alternating. Some of these are contortions, so it has a bit set, a bit cleared. And I have to make sure that I've got that for you guys to see. I guess the easier way for me to show that is I got it right. No, I want to go through, like, yeah, for the presentation to you guys of seeing basically 9A. I know this is convoluted. Looks like I'm throwing gang signs. So we just have to remember that sequence as I give it, because I'm going to go through and I'm going to do a quit to get out of debug. But let's go back to get up the information that I want to show. So this is me, August 28th, 2006, on the SIF news group of me posting information 11 o'clock at night. Working up late, coming across that stuff after I went through the Mall 30 technical reference, and I learned of this planar control feature, and so I'm going to go through and I got to get the ability to interact with the contents on the screen. I'm going to go through and scroll just to get through that one surprising function, particular I/O port register, controlling the built-in planar features except for the real-time clock. The hardware for each feature select line can be disabled by clearing a bit in the I/O register to 0. Of course, the saying is not preserved through a power cycle, and I put in parentheses, not a blessing, or I mean maybe a blessing, with read-write port 65 hex organized like so. And the reason I say it's a blessing in a sense, because you could go through this feature and you could disable something like the planar video or a planar function, and once you disable the video, you have no idea of how to turn that video back on in this case. And so all you have to do is power cycle. It's volatile. You power the system down, that register is cleared. Now it is interesting for the PS2 Mall 30 and the PS2 Mall 25. They are unique in that regard, that when you power the systems up, they actually determine that equipment configuration on the fly every boot, and they're unique for that. They're not like a 286 Plus system where they go through and have that CMOS configuration saved away and know what they're what's configured for them. It's not like the old IBM XTs and PCs where you set the dip switches on the planar to go through and change various things. The PS2 Model 25 and Model 30 go through and they figure out that equipment of what is supposed to be enabled at that boot up process. Now, as we look through, and I have the bit functions, and I have to get to the point where, I mean, 9 was easy for me. I think A was a little bit harder as it shows to you guys. I have to show it so it shows to you guys, and not how it it looks to me at this end. So as I say, 9 for those higher order bits, and that's bits 7, 6, 5, and 4. Okay, now bit 7, which is the highest order bit, that's this one. You know, that's set to a 1, but all that is that is a planar port output enable select. So it just controls how that parallel port operates. We'll get to the point of how to disable the parallel port later on. This just controls the mode. So as we get through, bit 6 and bit 5 are set to reserve 0. They're off. And that's the center fingers here I have in 9. And then the bit position 4 is serial port select, meaning that, you know, pinky finger in the grand scheme of things in that representation of 9 controls whether the serial port is turned on, enabled, or not enabled, disabled. So we'll look at that aspect. If we wanted to go through and turn that serial port off, we just set that to a 0. And so we have, an 8 in this hexadecimal value rather than a 9. So that's the thought of going through, and if we set that first byte of the register, or the first 4 bits of that byte in the register to 8, we turn the serial port, effectively disable it. Okay, so getting down to the lower bits, and that's where we had that A value. And so we have for bit 3, diskette controller select. Okay, so bit 3 is effectively this one, and I do on this MUL30 I'm using the planar floppy diskette controller FDC chip, because I'm running the 1.44 megabyte diskette drive for A, and that even the external 4869 drive that I have attached on the MUL30. I don't know if to do a side, if I'm even going the right side, I guess, to show that the external diskette drive for the B drive. So I am using that floppy diskette controller. It's passed through the adapter that's inside there. So that bit is on. For bit 2, that's the MCGA video. Okay. Now, in this case, on my MUL30, that's 0. It's off. And that makes sense because I have a VGA adapter in there. Okay. And that VGA adapter, when it goes through the boot cycle, it says, hey, I'm primary video. The BIOS extension of that adapter goes through and says, I've got to tell the system I'm the primary video to turn off what it thinks is primary video. So that's gone through, and that is actually the IBM Vga adapter. It was almost specifically designed for the MUL30. It's an 8-bit adapter that does VGA, and it has the potential, like I'm using it, to turn that MCGA video from the planar, disable it, then you have that adapter to take it up to the VGA level that the other PS2s had. So that's a logical jump to be in a MUL30. And that's why IBM has that video BIOS set and says, hey, disable that MCGA video. If you're in a MUL30, go through and do that. And that's not a microchannel adapter. That's like the MUL30, that's an 8-bit, what is treated as an XT adapter. It's not ISA, it's not 16-bit. It's not the AT bus, because that was 16-bit. It's 8 bits. So that makes sense for MCGA video being off. The next bit 1, we have parallel port select. Okay, so we have the instance where the parallel port is enabled on the planar. And again, that makes sense. I'm not going through and turning it off. There is a parallel port that's present on the system. Normally when the system is booted up, it detects that parallel port plus the serial port being there and goes through and enables those. Okay, the bit 0 is the hard disk drive controller select. Okay, and that also makes sense that that bit is cleared. It's 0, meaning that the planar hard drive controller is disabled. And remember, on my MUL30, I have a SCSI adapter in there, and that's how I run that 1 gigabyte hard drive that's in my unit. So by the same way, the system goes through and it turns off that hard drive connector, because there's no hard drive connected to that proprietary connector on the planar, and understands that there is either not a hard drive on the system. There were some Model 30s that just had the 2 diskette drives, or in the instance where that hard drive controller is being supplanted and being another controller is on the system. So that's what makes up the composition of the A being in the lower 4 bits of that byte value. So to go through for illustration, and we don't necessarily want to do anything with the diskette controller. I don't want to go through and toggle that condition, but the parallel port is another bit that we might go through and work with. Now, in this instance, if we go through diskette controller on, MCGA video select being off, parallel port select we want to turn that off, and then the hard drive controller select is off as well. So that is effectively an 8 as well. So just remembering, if we go through and we'll work with the 4 bits, low order and high order, to go through and on the to kind of toggle that parallel port and serial port. So what I'm going to do, let me go through and we're going to go back to getting that off the screen. We're to kind of this, the video capture I'm doing, I maybe should have gone through and done not a full screen capture with that HDMI that works a little bit better. I'm going to see if I can get it up into the and we went through and we did look at the parallel port, serial port being active. Okay, active. I did go through that. I apologize. Okay. Back out at the command line again. At least we have the screen in better condition. We're going to start up debug again. We're going to look at that value on port 65. It's 9A. Okay. So if we go through and we say output to port 65, comma, the value of 8A. Okay. We're back at the debug prompt. We just do quit Q for quit. We start up that UNPC program again. Okay. First, we're going to look at the parallel port. And it's still active. Okay. Go to the serial ports. Okay. And it's showing the serial port there. It's not showing the UART anymore of what detected on there, the chip that runs that serial port. But for active, it's saying no. Okay. And that's what we did, is we changed that 9 to an 8, affected that 1-bit setting, and went through and turned the serial port functionality off on the planar. All in software. Okay. And to go through and invert that again, okay, we go into debug, do an input 65, just to show we've got 8A in there right now. We want to go through, do an output to port 65, and the value of 9.8. So we're turning that bit for the serial port back on, but we're also, for the 4 lower order bits, we're going through and putting an 8, or effectively turning off the bit position 1 in that instance. We do Q for quit, start up our UNPC program again. Okay, system information. We'll go down to our parallel port. Okay, so, so that put on that extended mode. Interesting enough, it left it active. So I wonder, and I took that straight out of the tech ref. So that's a, worse than all, we're getting a learning experience here again. And of that port being active, let's look at, and we're going to go through and we're going to learn a little bit more hexadecimal as it is, it looks like. Okay. So, and that's what I'm struggling against a little bit with the tech ref. I'm wondering on the real-time clock whether it's actually off as well. So it's good for us to learn something. But we have that serial port set back to active, and it tells us what UART type we have on the system planar. So we're going to play a little bit more here. Okay. Going back out to DOS debug. DOS prompt to start debug. Okay. We're going to do an input for port 65 hex. Okay, we've got 9.8. Okay, so what I want to do actually in this instance is, let's go through the port that we're going to output. In fact, let's go through and we'll turn off the extended mode first. We'll just go back to the original. On port 65, we want to output the value 9A that we had to begin with. And case sensitive, it's not case sensitive either. Lowercase a, uppercase A means the same thing, hexadecimal. Okay, and that's, an A is a decimal. A in hexadecimal is 10 in decimal. Okay, and we're going to quit. Start up the UNPC. We're going to focus just on the parallel port now, that parallel port mode. Okay, so, and this is even turned into a little bit longer than what I wanted as well. Okay, so it's active, but it's not in that extended mode anymore. And that's interesting. I mean, that ultimately, the way that I read that technical reference and wrote it down. Okay, so let's go through escape. Okay, get back out to the DOS command line, run debug, and in this instance we're actually wanting to go through and change that initial file value. What we're going to do is we're going to go through output to, and again, we've got, you know, that the value of that port, we've got it as 9A right now. So if we go through output to port 65, and in this case, we're going to go through and we're, instead of the 9, we're going to go through and we're just going to have it as the value of just that, of working with those 4 high order bits. We're going to have a 0001, and then for the second portion of that, we're actually going to go through and in this instance, I think we're going to turn, because we want to go from A to to the value of 8 should get us to what we want. Okay. And then let's quit. Okay. And let's go through and start up the UNPC program again. Again, we're focused on the parallel port. Okay. Active and extended. I wonder if both of those because we left because I turned off that high order bit that I thought was that it turned off the port, and we're going through. Okay. Do we go through and this is a little bit of a learning experience. So that was active even with the value of 1.8. And we've gone through. Okay, let's do output 65. And we're going to do 1. We're going to do A in this instance. Okay. Quit. UNPC. Yeah, that works so well for the serial port. I'm wondering why the parallel port in this case is and it's still on and active in extended mode. Okay. Because we went through the prior time and we turned both the mode and the select off. That should have gone through, and now we're having where the select, what I'm thinking is the select, the highest order bit, bit 7, is off in extended mode, which I think is at bit position 1. Got that on. So maybe the parallel port, I'm not understanding things quite right, or why that is still active in this case. And I'm just wondering, is it a function of, okay, we're set to 1A. Yeah, and I don't think it did said the 1.8 before. That would normally go through and turn off that bit position 1. So there may be something I'm just not understanding. I thought this would be straightforward. I didn't go through and really prep for this. I just thought it would work as I intended. So I can't turn that parallel, and that is useful detail enough on its own. At least we've learned how to turn off that. Okay, so what I'll do here, I'm going to go through, I'm going to, just to confirm, we've got, okay, so we're going to go through and go back to a value of 9A, which is the original value that we had. Quit UNPC. Now that should turn off that extended mode as we saw before, or we saw originally on the parallel port. Okay, so extended mode is no now. So in this instance, it looks like the for that bit 1 position, if it is well, no, for the yeah, for that bit 1 position, if it's set, it's a 1. That extended mode is off, or it just says no for the extended mode here. If we clear that bit 1 position to a 0, it goes through and it marks that extended mode as yes, of being on. But there's just not any way that I've seen all the combinations. I can look at this again and see if I miss anything. But there doesn't appear to be a way to turn off that parallel port functionality like we are with the serial port, the demonstration I wanted to do. And so, I mean, that's enough of a lesson, I guess, in that. And it's made for a video that's a little bit over a half an hour. Just explain the functionality of one register here, and just me kind of stumbling through and actually learning that in one instance it works, in another instance it doesn't. At least it works for the MCGA video side and the hard drive side as well. Works for that serial port, but not the parallel port. So that's what we learned today. I think on an upcoming video, I don't know if it's going to be the next one or what, I'm still working a little bit in the same way with that real-time clock. And that is going through, and I'm having to identify some variations like this, or some aspects of it, how it rolls over, and learning what the values in those registers mean for the clock. And so there's a lot to address there as well. Hopefully that won't be a super long video, but we just roll with it as it is, and we both learn things. I mean, learning things of coming up on 14 and a half years ago of when I wrote this, that with this UMPC utility, I'm going through and learning that what I wrote down back then, the way that IBM stated in their tech ref manual, doesn't work as intended. Or in that case of the parallel port, doesn't do what it's supposed to. And I mean, it wasn't really any biggie, because, like I say, that this Planar features control register. That's model 30, that's model 25, and that Epson Equity IE model, since it clones the model 30 so heavily, that's the only units that are out there that have that as well. So, okay, it might be good maybe for me to pull out a model 25 sometime, and they pretty much have all the same chipset and everything else in there, but see if that functionality works like it should. Or I can have people watching this video. You can go through and, it's at your own risk. Don't put the wrong things in debug and corrupt your data on your computer somehow, right to your hard drive controller, and put a message on there. But you guys can go through and play around with this as well. Use the DOS debug to get in and view that, what the contents are of your port 65 hex on your system, to tell you what you have enabled. I'll link that that page that has that information as well, just so you guys can kind of see what's listed in the tech ref for these models. And by all means, if you know the values that you find, or if you need to correct me in some way, just leave that comment. I'll respond to it. If you like this video and it's really just off the wall content sometimes, please click on that like button. But this is IBM Museum. That's all I have for now. Thank you.